Well, welcome for today's topic, that is manufacturing, the conventional versus the advanced technologies which are upcoming these days. Manufacturing is basically a process of converting raw materials into products like this. It is merely a bar which has been reduced in a prototype one. It is basically added, it has certain values which is added to the particular product. A product is conceived which has a certain value to it, where it is basically a raw material which is converted into a useful product. It involves a large number of changes in between. Manufacturing is bit related to production, whereas production and manufacturing has a slightest difference, because manufacturing we do see various intervals is related to manufacturing of pans, manufacturing of automobiles, planes, or whatever it may be. Production could be understood as the production of crops. Manufacturing may involve a discrete products or continuous product. Discrete products means individual things, individual items that is being manufactured, such as nails, gears, engine blocks, or it might be as good as your automobile, whereas it can be a continuous product, such as a lengthy wire, plain sheets of wires, sheets, metals, pipes, tubes. As you can see, it is a conventional manufacturing. It is being shown here. A person manually handles the bar, puts into a certain machines, measures, do forging. They are making bolt heads here, putting these in the furnaces, then again in furnaces and the forges. Here everything is done manually. This is the conventional way of doing. See, chamfering. Here you will see that a person has put it into a certain dies and the chamfer is produced here. Whereas you can see here the same thing is being done apart from conventional way to a technical way. Here everything is done by machines. It is a kind of automation. Here human involvement is to minimum. Here you see the same bolts are being produced in the same way, but here is the minimum human intervention. Here the same chamfers will be done, but it is being done through presses directly. Just see, they are making bolt heads. These are the chamfers. Has been made automatically. Here you can see they are making chamfers for this. Whereas what we have seen is the machining of simple bolts and nuts. The profiles like these is to be machined by newer technologies. These are known as unconventional technology. Here what you are seeing, they are making a hole, a circular hole, perfect hole, which is being cut. It is known as water jet machining. Actually here machining is being done by a high stream intense stream of water. They are using water here. You can see very well here the water is made as a tool which is being used to cut into a thick plate sheet up to certain of the sheet thickness. Here you can see clearly. This is the basic difference between the conventional way the things are manufactured, whereas in the unconventional way. In unconventional way, you can produce the contours like these. These are the leaves which has been produced here, whereas in unconventional way, these are being done by hand, which is quite tedious, cumbersome process and cannot be done by hand manually. In these nowadays, these unconventional or the newer way of manufacturing is very popular. Why these are very popular? Design requirements has increased. There is a lot of contours, a number of changes is going on. We need to have more productive rather we say productive has been an absolute term. Now we need an economical methods which are needed to be absorbed or adopted. We need a conventional ways of doing the things. Here we can see there are different kind of operations which are conventionally done. See, this is a bar stock. A through hole is done in between the bar stock. It is known as boring. This bar is reduced into a circular bar. This is actually a rectangular bar which is turned into a circular bar. It is known as turning. It is given a shape by slicing operation. Slicing it in six different surfaces. It produce this kind of produce shape. This is known as milling. In the same part, the turning part, if we are doing a hole, that is drilling, these kind of things, these are the, this part can produce by number of ways, by different kind of conventional or unconventional kind of manufacturing process. The same can be produced by casting, where a mold is created, a cavity is created, and a molten metal is poured. It will acquire that shape. There will be a forming and shaping operation where within the presses the bar stock is placed and takes the shape of that thing. Where is the machining process? It is a subtractive process where layer by layer, as per the requirement, the parts or material is removed in the form of chips. It could be produced by joining, but joining is is a kind of process. Then there are various finishing operations to have aesthetic or some metrological requirement. It fulfills the metrological. So here it is shown. This cutter is being glided. It traverses through the bar stock. Bar stock is moving in this direction. Cutter is moving circular and is moving in this direction. It is using this material. These are the lathes, heavy machineries. These are being operated by manually. You can see there are various number of attachments here which has to be simultaneously dealt with manually. It is based on the processes and the type of product required. We could use ferrous materials, non-ferrous materials, plastics, ceramics, composite materials. This is basically flow charting, which defines from the starting to the product conception of the product, how does it takes place and where do we find various capabilities, various technology. It starts from the top, that is the need, where the need arises, then design comes, then evaluation, the iterations come, then prototype production or prototype making is conceptualized. It requires production drawings and various things, and finally it takes the shape of a product. With the advent of computer technologies, computer is being used everywhere in each and every field of humankind, such as computer design. Basically these are the tedious job documentation work which can be handled by computers. It may be production of drawings, it may be upkeep of the drawings, it may be upkeep of the materials, it may be the drawings analysis of the product to be made. Actually instead of making products, here the products are being tested virtually. Then comes the computer integrated manufacturing, which involves CAM as one of its. We had seen a lathe which was being operated by a manual person. Here it shows a CAM, the same kind of machine, but is being operated manually. This is known as CAM. CAM is basically computer aided manufacturing. Here manufacturing is done with an aid of computer, with the help of computer, where computer in various command controls the various axes and the movements of various movements of the frames or the arms of the machine, which I will later on. CAM is an integration of some CNCs, NCs and robots. Basically it is a robotic arm which acts as an aid in an environment. Why computer is needed? We can see a conveyor here. The material starts from here, goes through a processing line and goes out from the processing line. Here we have an assembly of 4 or 6 machines. these all machines are automated. These are self capable enough to do their job, but while loading and unloading these robotic arms of various fixtures are required. That's why robots are used, and that's why this whole integration is known as CAM. In very brief, these are basically we define all the motions into three basic motions. One is point to point, one is straight cut, another one, third one is contouring. Here you can see it is a drilling operation where we locate only one axis is automated. We locate at a point drill bit. We do the drilling operation here. This way it is traced back and it is located again on the next point where a next hole is to be drilled. In between there is no operation is being performed, whereas in straight cut this continuous cut can be generated with the help of and mill. But here the thing is that the motion is in two axes, that is in up and down. Here in this case up and down and the to and fro movement of the work table. Whereas in the case of contouring, whereas contours in three dimensions is x, y and z axis, the motions are possible. I will show what are those x, y and I'll show z axis, y axis and axis is when it is a coordinate system where your right hand, the three fingers, forefinger, pointing finger and the thumb is stretched apart at 90 degrees. If thumb is representing the x-axis, your pointing finger is representing y-axis, the z is represented by the middle finger. Then these are the axis which is being designated to a machine, and these movements in this movement in this direction from center towards right in x is known as positive, whereas center towards left is known as negative. Likewise in y and z axis. Machine to know the movement in x, y and z axis uses absolute motion system or incremental motion system. In absolute positioning system, the zero or the origin remains same, whether machine is here, here or whatever it may be, it is being counted from zero. Whereas in incremental system, the previous position is important. If we are moving from center to this position, it will be treated as 0, 1, 2, 3, 4. 4 movements in x, 2 movements in y. This will be 4, 2. If we are moving from here to here, this will be treated as origin. It will be treated as origin. X3 will be treated as origin for y4, where the movement x and y coordinates will be in x. It will be 1, 2, 3, 4, 5, 6. It will be -6, and in y it will be 1, 2, 3, -6, 3. One of the finest achievement of technologies is rapid prototyping in the field of manufacturing, which is layer by layer technology. It is known as additive technology. It is more generously or more famously known as 3D modeling. Here it finds a lot of application in surgical. Today's technology do involve artificial intelligence, artificial neural network, and various techniques. And cellular technology, group technology also plays an important. See how this movement is recognized in machining language. This is the top view. This is basically the workpiece. Here we define this as a home position. Here will be a tool bit. We keep on moving this. This tool bit moves from this. It is moving towards this. Then it goes inside the workpiece. It is basically drilling a hole. It goes beneath the workpiece to the desired depth. Then it is retract back. Once again we will see in a motion how it is being done like this. These are the various robotic arms which is being used. These are the very basic robotic arm. Cartesian coordinate system, spherical. Here the movement takes place in Cartesian, the cuboidal space. The up and down movement, to and fro movement, and back and forth movement. Likewise in cylindrical, up and movement and cylindrical movement creates a cylindrical geometry. Again, as you have seen, with the advancement of the technologies, the things are being made easy, but it requires a lot of attention and a lot of control. Thank you very much.